Hello. So let's move to the next topic of chapter 1. This will be the last topic in chapter 1 of plus 2 maths. So what is injective, surjective and bijective functions? We will see that first. So injective function means which is same as 1 function. Okay, 1 means what? Every element in set X will have at most a single image exist in set Y. For example, A has the image E, B has image H, C has image F. So all the elements of set X has a unique image in set Y, right? That is 1-to-1 relation. So this is also known as injective function. Then what is surjective function? Surjective function means every element in set X there exist the elements in set Y. Okay, so that all the elements in set X has a image in set Y. Okay, so every elements of set X is having a relation in the set Y elements or with the set Y elements. Okay, so we can see here A has the image E, B and C having the same image G, D is having the image Y, F, sorry not Y, F. So all the elements in Y is having a relation with elements in X. So there is no free elements or free images exist in Y, all are related with each other. Okay. Excuse me. So that is our onto function, and onto function is same as surjective function. So we have seen all this, what is 1 onto into functions, everything in the previous classes. So if we relate these two, can we say injective function is same as surjective function? You can see here injective function means 1-to-1. That means one element in X has at most one relation in set Y, right? So suppose if A and B is having the same image E here, for example, instead of this A and B is related with E, will it be a 1-to-1 function? No, this is not 1-to-1 function, because for 1-to-1 function every element in set X should have a unique image in set Y. Okay, so this will not be a 1-to-1 function. Okay, and if we consider the other case, so here suppose if we have one more element J. Okay, if we have one more element there, can we say it is an onto function or surjective function? We cannot. Why? Because in surjective or onto function, all the elements of Y such that there exist elements or there exist elements which are related with elements in Y. Okay, So every element in Y should have at least a single relation with X set X. Can we say, suppose if we have added an element J in this surjective function. Example, if we have added a J, can we say it is a surjective or onto function? Just think, will you say that? No, exactly not. Why? Because every element in Y, there exists a relation or a related element in set X. Okay, then only we can say it is as an onto or surjective function. So if a free element exists in Y means this has no relation with set X. So definitely this won't satisfy the condition of onto or surjective. Clear? Okay. Now what do you mean by bijective function? Bijective function means if both onto and 1 conditions are satisfied, then it is called bijective function. Onto means if this is X, this is Y, the elements in X should have at most single relation, at most a single relation exists in set Y, that is satisfied. So 1 1. So every element has a unique image, right? So it is 1 1. Is it onto? Is it onto? We'll check every element in Y, there exists a set X such a way that all the elements of set A is related with the elements of set Y. Clear? So all the elements of set X has a related element in set Y, or otherwise we can say every element in Y has a relation exists with set X. Okay. So onto condition also satisfied. So this is called as bijective function. So now we'll see the problems related with this. Okay, so we'll see the problem. Given A equals 2, 3, 4, B equals 2, 5, 6, 7, construct an example of an injective mapping from A to B, a mapping from A to B which is not injective, a mapping from B to A. So these are the things we are going to find out. Okay, so let's see the answer. Question is, we have to check or we have to create an injective mapping from A to B. Okay, so for that, if you see these two sets, we can write a function f such a way that X is the elements in set A, Y is the elements in set B. Okay, and such that this is the annotation for such that what is the relation with Y with X. Okay, so if you see this set, you can see 2 plus 3 will give us 5, 3 plus 3 will give us 6, 4 plus 3 will give us 7. Okay, it is not necessary that all the elements should be connected with B, right? Because it is an injective mapping. So in injective mapping means all the elements of the domain set should have a unique image in the codomain or set B. Clear? So if we take that relation y equals x plus 3, okay, then we can define here an injective mapping, right? So it will be 2, 5, 3, 6, 4, 7. See, so it is a injective mapping, right? Okay, so all the elements of set A has a unique image in set B. Clear? We'll check the next condition. How we can make this function as not injective? So what is the condition of not injective? If multiple elements maps to a single element in set B. Suppose two elements are mapped to a single image in set B, then it is not satisfying the injective function condition, right? So we have to construct a set like that. So if I take 2, 2, 2, 2, then 3, 5, 4, 5. See how it will be. So this is B, this is A. So this will be the set. So here 3 and 4, we have 6 and 7. Okay, 3 and 4 is mapping to same image in the set B. Okay, so we can define it as like this function or this set is not satisfying condition of injective function. So this is not injective mapping. Okay, so we'll check the last condition. This is a third condition, a mapping from B to A. Okay, so B to A means just invert the sets. Okay, so B will come as the domain and A will come as codomain. Okay, so here if we relate B with A, what will be the set we obtain? 2, 2, then 5, 3, 6, 7, 7, 4. Okay, you can have any kind of relations. Okay, but only one thing, our relation should be from B to A. Okay, so this is one possibility. You can have any different choices. Okay, so here I have chosen these relation. Okay, so this will be B to A mapping.